Conductors. Throughout this text, all references to conductors are for copper conductors unless otherwise stated. Basics of wire sizing and loading. The NEC defines a branch circuit as the circuit conductors between the final overcurrent device protecting the circuit and the outlets. See Figure 4-1. In the resonance discussed in this text, the wiring to wall outlets, the dryer, the range, and so on are all examples of a branch circuit. The NEC defines a feeder as all circuit conductors between the service equipment, the source of a separately derived system, or other power supply source, and the final branch circuit over current device. In the resonance discussed in this text, the wiring between the service disconnect that is located outdoors in the main panel board A and sub panel B are feeders. Generally, conductors are required to be protected from overcurrent in accordance with the conductor's ability to continuously carry current. Ampacity under the conditions that exist where the conductor is installed. NEC 240.4, a common exception to this is a motor branch circuit where it is quite common to have overcurrent devices, fuses, or breakers size larger than the ampacity of the conductor. Motors and motor circuits are covered specifically in NEC Article 430. The ampere rating of the branch circuit over current protective device, fuse, or circuit breaker determines the rating of the branch circuit. For example, if a 20 ampere conductor is protected by a 15 ampere fuse, the circuit is considered to be a 15 ampere branch circuit. NEC 210. Standard branch circuits that serve more than one outlet are rated 10, 15, 20, 30, 40, and 50 amperes. However, 10 ampere branch circuits are not permitted to supply receptacle outlets. A branch circuit that supplies an individual load can be of any ampere rating, NEC 210. If the ampacity of the conductor does not match up with the standard rating of a fuse or breaker, the next higher standard size overcurrent device may sometimes be used, provided the overcurrent device does not exceed 800 amperes. The branch circuit is that part of the wiring that runs from the final overcurrent device to the outlet. The rating of the overcurrent device, not the conductor size, determines the rating of the branch circuit. Feeding conductors are circuit conductors between service equipment and the final overcurrent device. Standard sizes for overcurrent protective devices can be found in NEC Table 240.6. This deviation is permitted if the circuit supplies fixed loads, such as for lighting, or not more than one receptacle for cord and plug connected portable loads. Keep in mind that a duplex receptacle is a multiple receptacle with two contact devices and one strap or yoke, according to the definition of receptacle in NEC Article 100. The informational note to this definition gives us guidance that this is intended to be counted as two receptacles on the same mounting strap. So the roundup rule does not work for branch circuits that supply multiple receptacles that can supply more than one cord and plug connected load. NEC 240.4. For example, a 6 AWG copper conductor has an ampacity of 65 amperes and a 75 column of NEC Table 310.16. Because this is no standard overcurrent device rated 65 amperes, we are permitted to round up to the next standard rating of 70 amperes. However, the load on the conductor cannot exceed 65 amperes. See Chapter 29 in this text for additional discussion on this topic. The amplicity of conductors commonly used in residential occupancies is found in NEC Table 310.16. This includes type NM cable. It is required to be manufactured with 90C insulated conductors. Typically, the insulated is type THHN, even though it is not marked as such. As a result, the cable is limited to use in dry locations. See NEC 334.10. A1. NEC 334.80 allows the 90C conductor ampacity to be used for durating purposes so long as the final ampacity does not exceed the ampacity from the 66 column of NEC table 310.16. The ampacity of conductors commonly used in residential occupancies is found in NEC Table 310.16. This includes type NM cable. It is required to be manufactured with 90C insulated conductors. Typically, the insulation in type THHN, even though it is not marked as such. As a result, the cable is limited to use in dry locations. See NEC 334.10A1, NEC 334.80 allows the 90C conductor ampacity to be used for durating purposes so long as the final ampacity does not exceed the ampacity from the 60C column of NEC table 3.16. The amphitheses in Table 310.16 are subject to ambient temperature correction factors that must be applied if high ambient temperatures are encountered. For example, were installed above heated ceilings. See NEC Table 310.15b1. Conductor amplifiers are also subject to an adjustment factor if more than three current carrying conductors are installed in a single raceway or cable, or if these cables are installed without maintaining separation. See NEC 310.15. See Chapter 18 of this text for complete coverage of the application of correction and adjustment factors. Note that the NEC no longer refers to durate or durating factors. The use of this term can probably be described as trade jargon. Wire size. The conductors used in electrical installations are sized according to the American wire gauge standard. The wire diameter in the AWG standard is expressed as a whole number. The higher the AWG number, the smaller the wire. AWG sizes vary from fine hair-like wire used in coils and small transformers to very large diameter wire required in industrial wiring to handle heavy loads. The wire may be a single strand solid conductor, or it may consist of many strands. Each strand of wire acts as a separate conducting unit. The wire size used for a circuit depends on the maximum current to be carried. The NEC in tables 210.21, 24, 1, and 2 show that the minimum conductor size for branch circuit wiring is 14 AWG, regardless of conductor material. Smaller size conductors are permitted for bell wiring, thermostat, wiring, communications wiring, intercom wiring, luminaire wires, and similar low energy circuits. Don't get confused. In the past, conductor size was shown as, for example, number 12 AWG. The same conductor now appears in the NEC as 12 AWG. The 12 is a size, not a quantity. Table 4-1 shows the typical applications for different size conductors. Solid and stranded conductors. For residential wiring, sizes 4, 12, and 10 AWG conductors are generally solid when the wiring method is non-metallical sheath cable or armored cable. In a raceway, the preference is to use stranded conductors because of their flexibility and ease of handling and pulling. NEC 310.3C requires that unless permitted elsewhere in the code, conductors AWG and larger must be stranded where installed in a raceway. The word ampacity is defined in NEC Article 100 as the maximum current in amperes that a conductor can carry continuously under the conditions of use without exceeding its temperature rating. This value depends on the conductor's cross-section area, whether the conductor is copper, copper-clad aluminum, or aluminum, and the type of insulation around the conductor. Ampacity values, also referred to as current carrying capacity, are found in Article 310. The most commonly used conductor ampacities are found in Table 310.16. The ampacity values in the tables are valid where there are no more than 3 current carrying conductors in a raceway or cable and where the temperature does not exceed 86 degrees Fahrenheit. These are considered conditions of use for the conductors. If there are more than 3 current carrying conductors in a raceway or cable, the ampacity values must be adjusted, reduced according to the factors in Table 310.15. This is because the ability for the conductors in the raceway capable are capable to dissipate the heat generated in current carrying conditions will be less than raceways or cables that contain 3 current carrying conductors or less. If the ambient temperature exceeds 86 degrees Fahrenheit, the ampacity values must also be corrected according to the factors found in Table 310.15. If both conditions are present, then both adjustment and correction factors must be applied. More on conductor ampacities, durating, adjusting, and correction factors is presented in Chapter 18 of this text. Conductors must have an ampacity none less than the maximum load to be served as shown in Figure 4-2. Branch circuits in dwellings rarely are considered as carrying a continuous load. Some branch circuits, such as for water heaters and electric space heating, are required to be rated not smaller than 125% of the load. See NEC 422.13 and 42.4b. We will review the application of those rules later in this text. The branch circuit for fixed outdoor electric snow melting and de-icing equipment is required to be considered a continuous load. See NEC 426.4 under the requirements in NEC 210.19 for branch circuit conductors and 210.20 for the branch circuit over current device. Both must be rated not smaller than 125% of the load. Even though these branch circuits are typically installed outdoors. A correction factor may not be required because the load on these branch circuits typically occurs at temperatures much colder than 86 degrees Fahrenheit. All conductors of a specific branch circuit must have an ampacity of the branch circuit's rating and be sized to handle the maximum load served, as shown in Figure 4-3. There are exceptions to this rule, such as taps for electrical ranges. See Chapter 20 of this text. Amplicity of flexible chords. Table 4-2 shows the amplicities for some sizes of flexible chords. Refer to Table 400.5A1 and 400.5A2 in the NEC for other specific types and sizes of flexible chords. Overcurrent protection requirements for extension cords are found in NEC 2040.5. Conductor sizing. The diameter of conductors is usually given in a unit called a mil. A mil is defined as 1/1000th of an inch. Mils squared are known as circular mils. Branch circuit conductors must have an amplicity not less than the maximum load to be served. 210.19a, C 210.23 for permissible loads on multiple outlet circuits. Branch circuit conductors must have an amplicity no less than the maximum load to be served. 210.19a, C 210.23 for permissible loads on multiple outlet circuits. All conductors in this branch circuit are required to have an amplicity no lower than the rating of the branch circuit. In this example, 28 conductors must be used, including for switch legs and travelers. See 210.19b, Table 210.24 and 240.4. Amplicity for some of the more common flexible chords used for residential applications. These values were taken from Table 400.5 AI. NEC referred to the NEC table for other specific types and sizes. Table 8 in Chapter 9 of the NEC clearly shows that conductors are expressed in AWG numbers from 18, 16, 20 circular mils through 4-0 to 11/600 circular mils. Wire sizes larger than 4-0 are expressed in circular mils such as 250 kc mil, 250, 100 circular mils. Large conductors such as 500,000 circular mils are generally expressed as 500 kc mil. Because the letter K designates 1,000, the term kc mil means 1,000 circular mils. This is much easier to express in both written and verbal terms. Older texts use the term MCM, which also means 1,000 circular mils. The first letter M refers to the Roman numeral that represents 1,000. Thus, 500 MCM means the same as 500 kc mil. Roman numerals are no longer used in the electrical industry for expressing conductor sizes. Overcurrent protection for conductors. Conductors must be protected against overcurrent by fuses and circuit breakers rated not more than the amplicity of the conductors. NEC 2240.4. NEC 240.4b permits the use of the next higher standard overcurrent device rating, as shown in Table 240.6. Permits the use of the next higher standard overcurrent device rating as shown in Table 240.6a. This permission is granted only when the overcurrent device is rated 800 amperes or less. For example, from Table 310.16, a 6 AWG conductor with type THWN insulated rated for 75C has an amplicity of 65 amperes. In Table 240.6a, We find that the next higher standard rating for an overcurrent device is 70 amperes, which is permitted to be used to provide overcurrent protection for the conductor with an ampacity of 65 amperes. However, the conductor is not permitted to carry more than 65 amperes. Non-standard ampere ratings of fuses Non-standard ampere ratings of fuses and breakers are also permitted. NEC 2040.4D spells out the maximum overcurrent protection for small branch circuit conductors. Table 4-3 illustrates the requirements of 240.4D. These are exceptions for motor branch circuits and HVAC equipment. Motor circuits are discovered in Chapter 19 and Chapter 22. HVAC circuits are discussed in Chapter 23. The rating of the overcurrent protection device, OCPD, determines the rating of a branch circuit as required in NEC 210.18. This OCPD generally will provide overcurrent protections for all conductors of the circuit. This means that OCPD will protect conductors from both an overloaded condition and when a short circuit or ground fault occurs. These are exceptions to this rule for specific conductor applications. See NEC 240.4G. This concept is shown in figures 4-3 and 4-4. For example, switch leg and travelers for 3 and 4-way switch loops are required to have the ampacity for example, switch leg travelers for 3 and 4-way switch loops are required to have the ampacity of the branch circuit rating, even though the conductors may carry only the load of a single luminaire. All three of these branch circuits are rated as 15 ampere circuits, even though the larger conductors were used for some other reason, such as solving a voltage drop problem. The rating of the overcurrent protection device, OCPD, determines the rating of a branch circuit 21018. Permissible loads on branch circuits. The NEC is very specific about the loads permitted on branch circuits. Here is a recap of these requirements. The load must not exceed the branch circuit rating. The branch circuit must be rated 10, 15, 20, 30, 40, or 50 amperes when serving 2 or more outlets. An individual branch circuit may supply any size load for which it is rated, NEC 210.22. 10 ampere branch circuits, they are permitted to supply lighting outlets. Dwelling unit exhaust fans, gas fireplace, individual branch circuits, NEC 210.23, must not supply receptacle outlets, fixed appliances except on individual circuits, garage door opens, or laundry equipment. 15 and 20 ampere branch circuits. They are permitted to supply lighting, other equipment, or both type of loads. The rating of one The rating of any one cord and plug connected utilization equipment not fastened in place is not permitted to exceed 80% of the branch circuit rating, NEC 210.23. Utilization equipment fastened in place other than luminaires is not permitted to exceed 50% of the branch circuit rating if the branch circuit also supplies lighting. Other cord and plug Other cord and plug connected equipment or both types of loads. The rating of any one cord and plug connected utilization equipment not fastened in place is not permitted to exceed 80% of the branch circuit rating. Utilization equipment fastened in place other than luminaires is not permitted to exceed 50% of the branch circuit rating if the branch circuit also supplies lighting, other cord and plug connected equipment, or both type of loads. The rating of any one cord and plug connected utilization equipment non-fastened in place is not permitted to exceed 80% of the branch circuit rating. NEC 210.23b1. Utilization equipment fastened in place other than luminaires is not permitted to exceed 50% of the branch circuit rating if the branch circuit also supplies lighting. Other cord and plug connected equipment or both type of loads. NEC 210.23b2. The 20 ampere small appliance branch circuits in homes must supply all wall, floor, and countertop work surface receptacle outlets in kitchens, pantries, breakfast rooms, dining rooms, or similar areas are not permitted to supply any other outlets. NEC 210.11 C1. 30 ampere branches circuits may supply equipment such as dryers, cooktops, water heaters, and so forth. Cord and plug connected equipment is not permitted to exceed 80% of the branch circuit rating, NEC 210.23. 40 and 50 ampere branch circuits may supply cooking equipment that is fastened in place, such as an electric range, as well as HVAC equipment, NEC 210.23. Over 50 ampere rated branch circuits are for electrical furnaces, large heat pumps, air conditioning equipment, large double ovens, and similar large loads. Aluminum conductors. The conductivity of aluminum is not as great as that of copper for a given size. For example, checking table 310.16, an 8 AWG copper conductor with type THH and insulation has an ampacity of 55 amperes. An 8 AWG aluminum or copper clad aluminum conductor with type THH in insulation has an ampacity of 45 amperes. And 240.4D, the maximum overcurrent protection for a 12 AWG aluminum or copper clad aluminum conductor with type TH in the insulation has an ampacity of 45 amperes. And 240.4D, the maximum overcurrent protection for a 12 AWG copper conductor is 20 amperes, but only 15 amperes for a 12 AWG aluminum or copper-clad aluminum conductor. Aluminum conductors have a higher resistance compared to a copper conductor. Is 20 amperes, but only 15 amperes for a 12 AWG aluminum or copper-clad aluminum conductor. Aluminum conductors have a higher resistance compared to a copper conductor of the of copper conductor of the same size. When considering voltage drop, a conductor's resistance is the key ingredient. Voltage drop calculations are discussed later in this chapter. Common connection problems. Some common problems associated with aluminum conductors were not properly terminated may be summarized as follows. A corrosive action, referred to as galvanic action, a condition when two electrochemicals dissimilar metals are in contact and a conductive path occurs for electrons and ions to move from one metal to the other. One metal corrodes as its ions are depushed into the other metal. This condition is set up when dissimilar wires come in contact with one another if moisture is present. The surface of aluminum oxidizes as soon as it is exposed to air. If this oxidized surface is not penetrated by the connector, a poor connection results. When installing aluminum conductors, particularly in large sizes, the aluminum conductor is scraped with a wire brush or emery cloth to remove the oxide. An antioxidant compound applied to the conductor just prior to termination may be required or recommended. The process of scrapping the conductor breaks throughout the oxidation, and the inhibitor keeps the air from contacting the conductive material. Thus, further oxidation is prevented. Aluminum connectors of the compression type usually have an inhibitor paste or compound already factory installed inside of the connector. Aluminum wire expands and contracts to a greater degree than does copper wire for an equal load. This is referred to as creep or cold flow. This factor is another possible cause of a poor connection. Prime connectors for aluminum conductors are usually longer than those for comparable copper conductors, this resulting in greater contact surface of the conductor and the connector. Older technology aluminum, such as Ally 1350, experienced the above problems. The newer technology aluminum, such as AA 8000, has much better conductivity, creep resistance, and strength. Still, extreme care must be taken when terminating aluminum conductors. The manufacturer of the aluminum conductor or connector will provide detailed installation instructions. Proper installation procedures. Proper trouble-free connections for aluminum conductors require terminal lugs and or connectors that are suitable for the type of conductor being installed. Terminals on receptacles and switches must be suitable for the conductors being attached. Table 4-4 shows how the electrician can identify these terminals. Listed connectors provide proper connection when properly installed.